Good day, ladies and gentlemen, and we are almost through with the paper one of the Gauteng Department of Education 2020. We are at the last little bit, which is kind of easy if you again know your theory. This specific section, probabilities, I've come to see is the worst answered because students get confused with all the different tools that we have in our pockets, where we get confused. Are we using Venn diagrams, two-way contingency tables, or are we using tree diagrams? But this one specifically is about a two-way contingency table. So let's journey through this question, but you first go and try it yourself. So hit the pause button, then come back when you've done this question. So a sports director at a school analyzed the data to determine how many sports of learners play sports and what the gender of each learner is. Okay. Now I'm going to say this very clearly. Now I'm not the sports director, but I can kind of give you a sneaky little bit of inside info. He was not actually just looking at learners and, genders and playing sport. What they are actually looking for when drawing up a two-way contingency table is whether the gender influences whether the kids will play sport or not. That's actually behind the story. That's actually where they are going. So in other words, does it matter whether a kid is male or female and their choice of whether they'll play sport or not? That's actually what is behind everything. So whenever we talk about independent events, I love to think about contingency tables, or vice versa. When they give me a contingency table, I know that the one question is going to be, are they independent? And look at question 9.3, independent events. So in other words, there are 120 males. Look at males total. Females, there's 160. How many students played sport? 100. Or 136, I mean. Does not play sport is 100. Ooh, I did not see that not there. Okay? So in other words, let's quickly look at question 9.1. Determine the probability that a learner selected at random is a male. Remember, we're looking at everyone. So how many males are there? So what I love to see is start at males, and does it stop anywhere? No. It says just males, so it goes through to total. So I love to pull a line straight through. There's nothing stopping me, so I'm going to go right to the end. 120. So my probability of males is how many males are there divided by the sample space, the number of people in my sample space. Now, how many males were there? 120. How many kids were there in total? Because remember, we are saying a learner at randoms. We're looking at all the learners. So 236. Now, I did not go and actually calculate the value of that, but you can do it. Okay, you can do it, go for it. But I'm going to go on to the next question. Now it says here, remember, determine the probability. So again, we're going to go probability of female and plays sport. Now, here's an important thing. Okay, you will see. I start with my females. I take it all the way through. But now, because they say and sport, I take that sport and I pull it down from play sport. And they meet each other in that block. So both of those kind of stop one another. Where they stop, that is 67 females that play sport. Okay, so these two little lines meet each other at the 67. So in other words, what's the probability that a person is male and plays sport? 67 over 236. There we go. Again, you can calculate this. Going to give you about 0.25 approximately. Okay, somewhere in that region. Now, if I look at question 9.2, are there events male and does not play sport mutually exclusive events? Whoa, big word. Mutually exclusive means that the probability of male and not doing sport is 0. Remember that mutually exclusive events mean it's two events that cannot happen at the same time. So the probability of someone being male and not playing sport is 0. Now that can't be true because there are 51 learners that is male and doesn't play sport. So can it be mutually exclusive? No. So plain and simple, it's definitely not mutually exclusive because that would mean that there are no learners that are male and don't play sport. Okay? But for 9.3, we kind of have to go now on to the next page. Okay, so on to the next page. Are the events of male and does not play sport, are the events independent events? So what do I need to prove for events to be independent? The probability of male and not sport must be equal to the probability of male times by the probability of not sport. That is what we need to prove. Okay, so get that. That is my RTP. Okay? If this is true, then the events are independent, meaning that whether it's male or female doesn't influence whether they're going to play sport or not. Independent events. So in other words, let's start on the left-hand side. What is the probability of someone being male and not doing sport? Well, again, if I take my male, it stops where it does not play sport. So 51 over 236. Now we do the same on the right-hand side. What's the probability of someone being male? Again, now I'm going to go and say there's nothing stopping my line. So it's 120 over 236. And again, not sport. There's nothing that stops it. So it's going to go, let me just do it in a different color. There's nothing that stops it going down. So that is going to be 100 over 236. If I multiply the right-hand side, I get 0.2154 dot, dot, dot. Now, are they exactly the same? Not close, not, if I round off to 2. No, are they exactly the same? And the answer is no. If they're not exactly the same, we can say that it's not independent events. Now, please get this. I know it sounds weird, but it doesn't mean there's a definite dependence. It's not that being male and female is definitely influencing playing sport or not playing sport. It's just that it's not independent. It just means there could be an influence, okay? There seems to be an influence, okay? But it's not that we are 100% sure. It's just that if we really want to check, we're going to have to take bigger and bigger and bigger samples until we are satisfied that it does play and does have an influence, whether you're male and female, whether you do sport or not sport. It's very interesting. I love probabilities because it kind of opens the door to a lot of things in future. Probabilities, which of course is hand in hand with statistics, is definitely a way of analyzing different events. It gives us tools in our pocket for real life to see whether one decision has an influence on another decision. But ladies and gents, stay tuned for our next video, which is going to be a lot of fun, about Venn diagrams. Our last video in this series analyzing a paper 1 from beginning through to end. So this is Mr. VG signing out. I hope you have electricity, because I don't. My electricity is gone. Recording by candlelight is awesome fun. So have a beautiful day. Good luck with your preparation for your finals. This is me signing out. Bye-bye.